start.
All right, thank you, Phil, and thanks everyone for attending again the seasonal symposium today. My name is Andrew Just here at Central Region STI, and you may know me well from the Forecast Builder training and the Forecast Builder application in general, but again, lots of support there going on for that. But for today's talk, I also have Patrick Guide, the Sioux in Duluth, Robert Deal, the Sioux in Philly, and also I want to acknowledge Mike Griesinger, who all these individuals have helped with this presentation. Want to make sure that everybody has the ability here to go into the PoEV here. You can see the address on top, as well as you can text it. We'll see that again here coming up. And really, this talk's kind of going to focus because we've, a lot of us have been utilizing the top-down or Burgoyne techniques for doing probably weather type. Now we're trying to migrate here over to the NBM because we're going to lose top-down here with version 4.1. And a lot of fields with that. So let me just jump right in here. I wanted to start right with key takeaways. Let's get these out of the way. No matter what happens with the rest of the presentation, let's get this done. So the number one key takeaway as we head to the NBM PoWTs is to think probabilistically. One thing with precipitation type is it's extremely sensitive. I think maybe a lot of you are probably aware to both synoptic pattern and thermal profile. Just small changes to a thermal profile can yield big changes to precipitation type in certain situations. Furthermore, the research that has gone into precipitation type has its own uncertainty, and observations themselves also have uncertainty. If you look at some of the automated observations, and that they struggle sometimes, for example, with sleet. It'll sometimes come out as rain, sometimes it'll come out with unknown precip, just awareness. And there's a nice article by Heather Reeves from 2016 that details about both the research and observation uncertainty. So as we get into modifying probability weather type, I would suggest only a couple different scenarios. One is that you're confident only one or two types will occur. Think rain, snow, for example. Or, a type will not occur. For example, freeze and rain. Finally, a significant upgrade is coming with regards to precipitation type in January 2023 with the NBM 4.1. It's about 3 months away from today. When that happens, you must recalibrate. And again, that the top-down grids are going away. So let's go to that first point on the key takeaway. And I'm going to open this up to everybody, which apparently is not going to work because I'm not signed in. So let's just pass this question because apparently it's not working. So what factors here influence precipitation type? Many of these you can think about. I've listed a whole list here. Precipitation rate, the presence of a warm or nose or cold dome, whether or not you have ice in the cloud to begin with, the size of the hydrometeor, and convection. All these, again, can modulate precipitation type. To recall from the Forecast Builder training, there's an item in here talking with the Burgoyne technique and a nice chart to describe where different types are favored or not favored. And you can see there's a specific zone in there where you could have a whole mix of various different types. And again, that points to some of the sensitivity here to the environment. So I do want to do a little think back here. So for the last several years, we've been applying either the top-down or Burgoyne technique, and usually that was done to a single model or a blend of a few models. And this approach is generally considered deterministic because you're creating probabilities based on essentially a single sounding. However, what if that sounding is just slightly wrong? For example, a storm system moves slower or faster and or farther north or south than expected. So we can get that uncertainty associated with that inclusion with the NBM PoWTs. It will bring in the model spread. And so that makes it now a probabilistic approach. So as we go through this, it's like, okay, can we still apply any of this stuff that we've learned about top-down or Burgoyne to help adjust the NBM probability weather type output if the, say observations are not lined up with the NBM? The answer is yes. All right. The next question here I would ask is, can conceptual models explain why the NBM PoWT is doing what it's doing? And that is also yes. And we're going to kind of run through this. Since I've had a little problem here with my poll, with the poll everywhere all of a sudden, I'm going to start with this first example, and maybe we could just do a quick raise of hands or something like that. Based on this sounding, what would be the predominant precipitation type? Does anybody want to raise their hand and answer the question? If not, I do have Patrick and Robert. Do either of you want to take this from?
This is Rob. So audience participation is preferred. So if anybody wants to kind of, take your shot at it, let us know what you think is actually occurring at this particular time.
Rain, freezing rain, sleet, snow. Are there any hands raised, Phil or Steve?
We had one person put in, several have put in freezing rain or freezing drizzle.
All right. I like that. So yeah, let's
the 32.
Yeah, it's a tricky one because your temp is right at 32. The dew point is 31. So let's talk a little bit about this. So here's the forecast and the outcome. So on the left is the probabilities of freezing rain from version 4.0. Remember, version 4.0 is a conditional, so whether or not precipitation is occurring or not, it gives you a probability. Bottom left is version 4.1, and what's cool, if you look at the probabilities, you see that there's probabilities extend pretty far back to the northwest in 4.0. Yeah, those are pretty much gone, in 4.1, and that makes sense. Again, some of that's probably that conditional, unconditional framework, but some of it's also just 4.1, I think, doing a little better job here at identifying the precipitation type. On the other hand, the plus sign here is where the Davenport observation is. Again, it's reporting based on the observation. It has missed at this point, but there's ice accumulation that has been occurring at Davenport, and you're not really seeing that in the probability spectrum, albeit it's just off to the northwest. So this might be one of these situations where we just need to just drag the whole, either drag that freezing area farther to the south and east, or just expand it. I will say that if you look at the surface observations, there's like a lot of mist, a lot of there's a freezing drizzle at Des Moines, some stuff going on in southern Wisconsin that makes you think that there could be some freezing stuff going on. So it's pretty, it is pretty close to what's going on observationally. All right, example number 2, and I like this one. I hope I can get somebody to raise their hand on this one for sure, because I'm just going to give you these 4 probability of precipitation type graphics. Can you explain, let's just say in an AFD, conceptually what's going on? Can you develop a conceptual model from this and describe it? Does anybody want to open themselves up and describe this situation?
And if anyone raises their hand, I can easily unmute you. Okay. Brett, he typed in warm air advection atop a stationary boundary, uncertainty with the position of the front. And Jenny typed in, looks like a surface low moving along I-44.
Oh, I like it. All right, well, let's see what actually happened. So here's the observed soundings. Recall that was a 49-hour forecast. So yeah, you have this Canadian high situated, up to over northern portions of the U.S. That's just slid south, and it's continuing to dive south, and you're feeding that cold, dry air down at the low levels near the 925 down to the surface. Meanwhile, you've got this upper trough situated off to the west, warm air advection, moisture advection coming up off the Gulf of Mexico over right in that front. And yeah, it is pretty much a stationary boundary as described. And so yeah, you're getting this swath of sleet and freeze and rain. And there's a lot of overlap because, as shown earlier from the Burgoyne diagram, that you do see these regions where, again, you're going to end up with a lot of mixed p-type just from an observed sense, but then you throw in the fact that it's a 49-hour forecast, so you've got to add in the little uncertainty where that friend genesis type zone is located. And if we go into the actual observed soundings from Springfield, looking at see how well did the 4-1 in this case types verify relative to the sounding, and you can see that there is a warm note. First, there's no ice to begin with from higher up. It's a dry sound in a loft. You get a warm note, so you're starting as rain, and then you fall into this cold dome. The cold dome is actually fairly deep. In fact, the coldest temperature gets down below -10. So you kind of see that, well, it could either be in a freeze and rain situation, or you might get ice nucleation down below that -10 area and start to get some sleet production. So I think it lines up very well with what the forecast p-types were. In fact, here's the actual observed, and you have freeze and rain and some unknown precip, so you're bouncing around between a lot of different types there. And farther east to Wilmington, where the plus sign is, here too, a little bit of a warm layer, not that great. You got a loss of ice aloft, so you're kind of leaning more towards a freezing, maybe a freezing drizzle type situation. Hard to say. And then that cold dome, maybe there's a shot for refreezing in there. So I think that lines up pretty well too with what you see in the probabilities. Unfortunately, most of the observations didn't have much precipitation at this time, which these NBM 4-1 are conditional probability or unconditional probabilities, so it factors in whether or not precipitation's occurring in the first place. So I think having low probabilities from that sense also makes sense, and you only see sleet observed there at the or some sort of unknown precip. It could be sleet, could be freezing drizzle, could be any of those types there at the early part of that time period. So let's talk a little bit about some known biases. We had our NBM PoWT test bed and develop a report, and a lot of these findings were passed along to NBM developers, which were helped to feed what's going on with version 4.1 and the improvements that help happen there. So the first bias is some of the stuff that can go on with the lower amount of members in the extended, where you can result in this latitudinally odd feature here with, like, for example, freeze and rain, where you have freeze and rain, it drops out, and then you have it again going from south to north. So again, with a big increase in membership that goes on in the extended with version 4.1, pretty much removes this issue entirely. I did want to note that there's this p-type display on the right will be something that we'll include in the forecast builder version 10.5 install. That was courtesy of Greg Mann at Detroit has created that, so we're going to try and get that out to everybody. Freeze and rain probabilities can get overproduced in cold dry solutions, and this could be a problem, particularly ahead of incoming precipitation, where you have a warm. The ones that are precipitating are warmer, and the ones that are cold and dry suggest a freeze and rain outcome. So this is something that's going to go with 4.1. Bias correction to IRMA. This is an issue that's really plaguing 4.0. We're actually seeing it going on right now with some of the rain snow mix situations. It can have negative impacts. There's an example shown here, but again, like I said, there's some of this rain snow stuff where the NBM right now is coming out of a warm period, and so the bias correction tends to want to throw off the temperatures to lead you to more rain. 4.1, we're not doing a lot of that stuff, so again, that makes the probabilities more useful. Another item here is this has different issues between 4.0 and 4.1. So if the NBM doesn't produce a precipitation type, but it is precipitating, in 4.0, you'll get a p-type produced because, hey, it's always producing a p-type no matter what, but it could end up being the wrong one because, hey, the NBM is probably going to end up being a warmer leaning towards a rain situation, but the actual result ends up being colder, and we have snow, due to wet bulbing effects or whatnot. In 4.1, there will be no, 4.1's unconditional, so it's no p-type produced. So Forecast Builder actually has a few assumptions in there that can help create a precipitation type, so you don't end up with a pop with no precip, and that's documented in the training. Finally, with Forecast Builder, there's a freeze and rain issue here. If you get like rain, snow, for example, and you see freeze and rain being outputted, you can quickly get rid of that. So the reason that you might get this freeze and rain here, and it only is going to happen here with version 4.0, is what Forecast Builder tries to do is it combines rain and freeze and rain together into one, and then splits it out based on your hourly temperature below 32. So if you don't want freeze and rain as an outcome, just deselect it out of the Forecast Builder GUI. And now I want to go to just a couple testimonials. Patrick, you want to start?
Yes, Andy. Sorry, I had to find my unmute button as I'm sitting on the forecast test today. We've been using it, at least at Duluth, for about 2 years now. So we have a little bit of a head start just being in the official test bed and then kind of in a continuation of the test bed from being last year. So I don't have a whole lot to add onto what Andy went through. I'd say for the most part, our big systems, big synoptic systems, it's handled very well. The trouble, from our experiences had been, and in some respects is going to go away to a good degree with 4.1, the way that everything is conditioned. It's just some of the smaller events where it's weaker forced, and it kind of gets back to the troubles that we would have dealt with anyways, say in a legacy framework and the wonderful ProbICE present grid. Again, a lot of that does start to go away with version 4.1 as we try to weed out some of those dry solutions. So from our experience, the big systems, minimal edits. If there's something, if there's a signal out there, just because there's freezing rain or sleet on day 5 or 6 doesn't mean we have to just automatically get rid of it. Especially with the move to 4.1, having such a large membership, there's probably a good reason to keep it in. And then we've seen, a little bit of the challenge is still always trying to land the forecast and shifting probabilities around when you're looking out the window and things are not matching up exactly. And there are a lot of tools and there are a lot of documentation how to use those tools to shift the probabilities around. So the ESTF is always the biggest challenge. Like anything, there's going to be some hurdles in just learning the methodology, but once you do that, and if you just, I think the thing that we try to talk to our forecasters about is just think of this, that it's a numerical version of the weather grid. Don't worry about conditionality, unconditioned, conditional. That just makes your head spin. It's a numeric version of the weather grid, and you're just kind of passing probabilities around it. You have a lot more power, but like anything, it's going to take a little bit of getting used to. So we're happy to help. The Forecast Builder team's happy to help. So if you have any questions, you can feel free to reach out to me, and I can certainly help as much as I can. So that's all we know from Duluth, where winter has already arrived. So I'll pass it over to you, Andy, or Robert.
Yeah, Robert. Thank you, Patrick, and yeah, Robert, take it away for yours.
Sure. Yeah. So most of my experience, obviously, using the new Forecast Builder was as the SU of Binghamton, and we've got quite a variety of issues up here in upstate New York. Ranging from terrain to lake effect, and a lot of the things you guys are facing across Central Region. And one of the things that I found with forecasters using it here was just the fact that there is a pretty strong initial learning curve to switching from the top-down methodology to switching to a PoWT methodology. But what we found was, and Patrick actually just alluded to this, for most of our events that quote unquote actually matter, our bigger events, the ones we can't afford to get wrong, it makes the forecast process easier and repeatable. And that's the big thing for me, is just that I want to make sure that from shift to shift, the forecast process and desired outcomes are a skill that we can easily repeat. And once you've cleared the initial sort of barrier to entry and that hurdle, forecasters can actually see what's going on. And you can actually look and tangibly see, okay, I'm forecasting a slight chance of this precipitation type. I'm forecasting a chance of this precipitation type. Okay, it makes sense why I have this the dominant type. And so you can look at that sort of numerical probability of the weather types, and it starts to just make more sense for the forecaster, which is something that I've been really proud to kind of watch, because you can definitely see more confidence from forecasters stepping into a extremely messy mixed precipitation system. And that's pretty much a lot of what we have around here is just you get warm air advection pushing in from the south, and then all of a sudden there's going to be some sort of rain, snow, sleet, freezing rain line in almost every single one of our systems. Thankfully further north and west, most of the systems just snow, but it allows a forecaster to be comfortable making quick decisions in a repeatable manner. And I look forward to kind of continuing that as we move, I start as the Sioux and Philly towards the end of November. And, it's definitely going to be a challenge, on the I-95 corridor as well. There's always rain or snow, and there's always sort of mixed precipitation. But the specific area that I wanted to kind of highlight, and it was actually, denoted here, was that, we had an abnormal heavy wet sleet situation where, it wasn't necessarily something we initially expected. And we had this blanket of sleet that just kind of put 2.5, 3 inches of sleet across, portions of our area. And as we did the event review, that the theme about using the new forecast builder and using the experimental version made things easier for forecasters once they understood it. And that's what I would really kind of want to, as your take home point, is that once people take the time to learn it, the newer forecast builder using the unconditional probabilities, it makes more sense visually to a forecaster, and it becomes easier to reproduce and easier to forecast. So with that, I'd certainly kind of answer any sort of questions that anybody might have, but I'll turn it back over to Andy.
Yeah, thank you again, Robert, and again, Patrick. We're short on time, so I do want to go through here really quick. Some references. If you haven't already, make sure to go through the winter section of the Forecast Builder training plan, and there's some job sheets with a pseudo-west simulation there. There's this link too for a 2-pager, and it's shown here at right. Patrick was a big help with that, along with Ted Ryan from the SUA down in Fort Worth, and have a printout readily available, maybe next to your workstation. And as always, questions, feedback, email the website address or email address there, and we will be glad to answer them. And again, this is going to be something we'll keep improving on over time. We did that with top-down Burgoyne. We'll do the same thing here with the NBM PoWT. So that's all I have. Back to you, Phil.